Hi, my name is Saeed, and I would like to talk about the work of Jordan, myself, Ari, and Professor Körding on object-based attention through internal gating. Let's imagine we are in a museum and we see this beautiful painting, but it's unfortunately too large for our brain to process at once. So what we often do, we look at one part of the image, we attend to that object, we process it, and then we move on to the next object. We again process that object, we try to understand its meaning, move on to the next object. And while we are doing this, we usually don't look back. We attend to the objects in the forward manner and we don't look to the object that we have already seen. So the objective of our project was to develop a model or build upon already existing models and add more biologically inspired features of object-based attention. So, what are the elements of object-based attention? So we know attention changes the activities of the neurons, so it modulates the activity, but it does not change the basic characteristic tuning of them, but rather the activity amplitude. One of the ways that it is assumed that brain achieves object-based attention is internal gating or masking of the objects which the brain is not attending to. And I would strongly recommend you watching this video selective attention test by Simmons and his colleagues. Another thing we know about object-based attention is the top-down neuromodulation of attention. We know not only that there is a feed-forward propagation of information in the visual pathway, but also there are lateral and feedback, enabling the brain to also regulate what it's attending to. And finally, the last one I'm going to talk here, but there are of course more, is inhibition of return, as I mentioned before. So while humans usually don't go back to the objects they have seen in the same scene, and they move forward sequentially. So the backbone of our model is UNIT. UNIT was developed in 2015 by Roneberger and his colleagues. It includes convolution layers and it has autoencoding structure. Also, it includes skip connections or lateral connections. It takes an image and in the output, it gives us the segmented image with all the objects segmented out. So what Jordan did, he added recurrency. As we have seen, there is recurrency in our visual pathway and everywhere in the brain, and also inhibition of the return, which is more biologically inspired. And we could add these by adding masks or internal gating as a recurrent layer. Well, does it work? So for the first experiment, we overlay 2 digits from MNIST and we showed it to the network. The network has to attend to one of the digits and ignore the other one or mask out the other digit. And also it starts building the inhibition of return mask. And then after it has attended and classified that digit or recognized that digit, it should move on to the next digit, mask out the previously seen and update the inhibition of return mask. And it does it perfectly. So the model can learn and do this. One thing that we could see is the attention invariant tuning. So if we look at the neurons, especially in the first layer of our model, we see that although the activity of neurons that are involved in the attention is improved, their shape is not changed that much, which is something we previously called attention invariant tuning. We also tried to reproduce an experiment by Rolfsson and his colleagues in 1998 on object-based attention. So they did this experiment with macaque monkeys. We're going to do it with our neural network. We show an image of a fixation point to our network for 3 iterations, and then we show 2 digits, one of them overlapping with the previously shown fixation point. And the network has to attend to that digit and not to the other. So it should mask all the other digits. And the network can do this easily. We then again reset, we show the fixation point, but this time for the second digit, and again the network has to mask out the other digit and keep the one with overlapping. We call the digit 4 here the target when the fixation point overlaps 4, and we call it distractor when it's not. So when it is the distractor or it does not have the fixation point on it. And we can record, or in the computer we can save the activity of the neurons on receptive field of 4 for both when it's target and distractor, and we see that the activity is modulated heavily when it is being attended to, so positively, for the neurons in the receptive field. We then reformulated the activity of all the neurons in layer 1 in all the receptive fields and put them in the modulation index, and we could see that the neurons are almost always positively modulated when they are part of the target digit. Of course, we did more analysis, and Jordan even worked on COCO dataset, so I would invite you to look at the preprint. We will update it soon with more analysis included. And finally, I would like to thank Jordan. He did most of the work, and also thank Ari and Konrad for their support. And thank you for watching this video. Thank you, and hope to see you on the live session and in the Discord. Bye-bye.